Good day, and welcome to this session from Scalyr, talking about the impact that Kubernetes has had on DevOps as it's advanced. With me today is Czerwinski. He's one of the co-founders here at Scalyr, and with his background, he's qualified to talk a great deal about how DevOps has changed with the impact of Kubernetes and where we go in the future. With that, let me turn it over to you, Stephen.
Thanks, Dave. Yes, this is definitely a topic that's near and dear to my heart. With my background, I've actually been responsible for running a lot of very mission critical and very large scale services in the cloud. And I think over the last 15 years or 14 years of my professional life, I've been on an active pager roster. So this idea of DevOps, this idea of how do we run production services well? How do we monitor them? How do we make sure that they're getting great performance is something that I'm highly interested in and very excited about. With Kubernetes, it's definitely already had a big impact on the field of DevOps, and I think that there's going to be a lot of changes in the future. So let's first set the context for Kubernetes. And here I wanted to highlight a bunch of the features that Kubernetes provides. And there's no way we'd be able to talk about all the features Kubernetes has in an hour-long talk, let alone one slide. But what I wanted to do here was highlight the ones that I feel are most germane for this discussion. The first three here are really about this idea of describing your infrastructure from a logical point of view rather than physical. So for example, with automated scheduling, this gives you the ability to specify policies such as I want this image thumbnailer. I want 5 instances of this image thumbnailer running in my infrastructure, right? You can describe that to Kubernetes. It decides how to make that happen in the physical world. Well, I'm going to run, 5 copies on these particular machines and go from there. Along with that, it has self-healing capabilities. So it's not only that you told it to start up 5 image thumbnailers, it will make sure that 5 image thumbnailers are always being run. So if one of the nodes goes down in your Kubernetes cluster and one of your replicas gets kicked off, Kubernetes will handle automatically finding another healthy node and starting up a new replica of that. And this really does go towards the idea also of you starting to think about your infrastructure in terms of resources and not machines. I have a terabyte of RAM and 1,000 CPU cores available to me. Not I have 500 of these type of machines and 300 of these type of machines, and you have to figure out how to mix and match all those resources to run your applications. Kubernetes also has features that's enabling microservices. Everyone's talking about microservices these days, for good or ill, but it's definitely a good tool to have in your arsenal as you're building your applications. Kubernetes facilitates this. It has built-in primitives that allows you to define your application as a service. I can take those thumbnailers. I can say those 5 replicas of my thumbnailer represent a service. And maybe I want to be able to allow my web application to use that thumbnailing service in order to do image transformations, right? So now we have this notion of, okay, it's represented as a service and we're allowing it to be discovered by other applications. When I define my web application, I can just make a reference to that thumbnailing service. And when Kubernetes goes to start up my web application, it'll automatically hook it up to the correct service. You don't have to worry about those details. The next really important feature and kind of shift that Kubernetes is making is this idea of infrastructure as code. I'm going to talk a little more about this in the next few slides, but the idea here is that you are able to define your infrastructure almost as source code. You define these are the elements, these are the applications that make up my infrastructure. This is how they fit together. And anyone coming in can read that source code, can get a picture of what your infrastructure looks like. You can actually almost understand in terms of comments being added how things kind of fit together. It's a much better answer than telling people, oh, you want to know how our infrastructure looks? Go to the AWS console and just explore around. Okay. Kubernetes also has a very expressive and powerful permissions model. They have role-based access control. And what this allows you to do is set very precise policies to enforce, whatever operational policies that you want to enact, right? You have the ability to say, okay, well, this particular team of developers get this amount of resources or get access to this job that they're responsible for running. So it really does help out kind of developers, and we'll talk a little more about this, in terms of allowing them to take a step back from enforcing all these policies themselves manually. Another great thing about Kubernetes is it has some very powerful mechanisms to allow for rolling out new changes to your code and rolling back if they're not working out so well. While I was at Google, we had a lot of very advanced automatic rollout procedures that allowed us to very safely roll out changes to code. And I always missed those when I left Google, but it required a lot of infrastructure and kind of mechanisms in order to support those. Well, with Kubernetes now, all developers get access to that. Kubernetes also is a very cloud-native technology. It has built in this idea of very easy horizontal scaling and load balancing. I have my thumbnailer job. I have 5 replicas of it. Well, what if all of a sudden I have more work I need to do than those 5 replicas can handle? It's trivial to say, okay, let's spin up 50 more, let's spin up 100 more, as long as you have resources in your cluster. And then the load balancing, the service discovery all kicks in, so your thumbnailing requests just automatically start flowing across all those different pods. And then finally, along the lines of allowing you to better describe your own infrastructure, Kubernetes gives you primitives for attaching metadata, things like annotations, labels, and namespaces to your applications. Again, this is a way of allowing you to kind of describe your infrastructure, to add in additional information so that people can walk in and kind of more easily see how things fit together. And for us at Scalyr, this is a feature that we love to leverage. Folks that use Kubernetes, they put a fair bit of time creating these annotations, creating these labels, allowing them to do things like, okay, these applications belong to my staging environment. These belong to my production environment. Maybe this is part of the image processing pipeline. This is part of our database application. Well, here's a screenshot of what you see as a Scalyr customer when you're running Kubernetes. We're able to leverage all that metadata that they've associated with their applications, and we're now able to provide a very kind of tailored view of their infrastructure, organized by all this great metadata they put in. All that hard work they put in, they now get to use that while they're exploring their logs, their metrics, and everything else on Scalyr. Okay, I'm not going to spend a lot of time on the Kubernetes architecture, but I did want to highlight a few things. First of all, resources in Kubernetes are organized by cluster. A cluster is a set of nodes that basically defines how much physical resources are available to run applications on that particular cluster. Every cluster has a Kubernetes master. And in fact, in highly available setups, of course, you have multiple masters, so that if one goes down, then there's a replica that you can fall back to. The goal, the job of the master is to take these logical goals that you've set, such as run my 5 replicas of this thumbnailer, and make it a physical reality. It is the schedule. It is the thing that looks at the desired state and figures out how to make that happen based on all the nodes and resources it has access to. Okay. Now, on the other side of that, you have the Kubernetes minions, the Kubernetes nodes. These are the machines upon which your applications actually run. Each of these nodes have what's called a kubelet. The kubelet works with the Kubernetes master in order to learn what jobs, what pods the master wants that particular machine to run. It keeps the master up to date about the healthiness of those pods, and essentially it is the thing that helps identify when there are problems on the node and when jobs need to be, or pods need to be migrated to other nodes. Okay, as we spoke about, Kubernetes has already had a big impact on DevOps. And I think one of the places where you see that most is it's continuing this trend that we're seeing where DevOps is becoming more of a role of facilitators rather than gatekeepers. In a Kubernetes world, the DevOps team, the operations team, is able to create a Kubernetes cluster, to add resources to it, to define how those resources are used by developers. This team gets to use 1 terabyte of RAM. This team gets to use only 100 gigabytes and commensurate CPU as well. The DevOps team is able to set these policies, and then the developers themselves are able to launch their applications. And the developers can do this because running applications on Kubernetes is very easy to do. There's easy-to-use command line tools. There's other environments that you can use. The bar for a developer launching and using applications on Kubernetes is very low. But with all the machinery and mechanisms that Kubernetes has, you as a DevOps team can rest assured that the policies that you set are going to be enforced, that there's isolation between these different developers' applications so that they can't hurt one another. So you're really much more in the role of being a facilitator rather than a gatekeeper. One of the other best practices that we're seeing being adopted more is this idea of infrastructure as code. Kubernetes by no means is the first system that had the idea of infrastructure as code. But I do think that it's probably the most popular system that has it. And so for a lot of users, this is the first place that they're seeing this idea. This idea that you get to describe your application as if it was code, how it all fits together. And here, this is all about leveraging great ideas from software development itself and applying it to the infrastructure world, right? You have the same goals. In software, you want to create maintainable, reusable code that's testable, that folks can look at and easily understand how it works. The idea behind infrastructure as code is that you want those same goals for your infrastructure itself. So you want it to be maintainable, you want it to be extensible, you want it to be testable, right? And so you have this idea that in a textual format, you describe how your infrastructure fits together, what applications are run, how services are connected together, what are the resource requirements, how much RAM, how much CPU does this one get, and so on. And so you're able to, in this textual form, see all this information about how your infrastructure is actually run. You don't have to go to the AWS console to see, how much RAM a particular job has. The nice thing is also you're able to leverage then a lot of the great tools that the software development world has. For example, you can actually use Git to track the changes made in your infrastructure over time. And, heaven forbid, you can actually use pull requests to make changes to your infrastructure. You want to up the amount of CPU allocated to your web application? Okay, create a pull request where you change that. And someone else can verify if that's a good idea or not. This diagram is really meant to just drive this analogy home. Just comparing the different steps, between infrastructures and applications. At the highest level, you have the application you want to create, the kind of like the logical requirements that your product team came up with. From infrastructure, you have the same thing. We want this service to run with these applications connected in this way. Okay, you represent that information. You encode those goals in source code or the YAML manifest files. And then you have something that turns that into the actual desired reality. In the case of development, that's your compiler interpreter. In the case of Kubernetes, it's the Kubernetes master, the API that it uses. Okay. Other practices to consider. And I hope that a lot of you are familiar with some of these practices already, but in case you're not, this is one of the things that I was excited about when I first started using Kubernetes. It's access to these very powerful rollout mechanisms that allow you to essentially roll out updates to your applications with zero downtime and allow you to practice more, advanced, maybe more risky techniques such as testing in production. Okay. For example, one of the update mechanisms that Kubernetes provides is a rolling update. So what I can do is I can say I want to be able to update my thumbnailer service, but when I have an update to the code, I don't want to restart all 5 replicas at one time. Instead, I can set a policy only restart 2 at any given time. So I know, while I'm serving live traffic, at most 2 of my replicas are down on the ground. The other 3 are serving traffic, and so I can make sure I've got things provisioned appropriately. But it also has mechanisms in place to make sure that the updates are being applied in a safe way. Essentially, Kubernetes has a way of knowing when that replica is ready to serve requests. So I've restarted a given thumbnailer. It's coming up with a new code. It's able to signal to Kubernetes, okay, I'm up enough where now I can start receiving requests. Only then does the rolling update proceed to the next one. So for sure that you have at least 3 replicas that are serving live requests. Similarly, you can do things like blue-green deployments. You can do canaries, and Kubernetes will help you, monitor, the health of those different setups and allow you to do rollback as necessary. One of the other practices, I mentioned this earlier, role-based access control. In some ways, you could complain that Kubernetes has too fine-grained control when it comes to the permissions that you can set on the various resources and entities, Kubernetes entities that you have. And that's true to a degree, but it's fine-grained enough where you can set very expressive policies that allow you to represent your operational goals. You can divide up resources by team. You can grant access to logs based on what team the members are from. You can split up resources by namespace. There's just a lot you can do, and so it's an opportunity for you to really kind of spend a little time, make sure that you got the policies you want, and then you can step back and have a lot of faith that Kubernetes will keep your developers in line. How do you manage your deployment in Kubernetes? And this is really kind of almost like a hello world. What are the first steps that you need to do in order to launch your application on Kubernetes? It's fairly straightforward. The first thing you want to do is define this YAML file that we've been talking about. It's the Kubernetes manifest file. It defines such important attributes as what's the image that the container should be running when it comes up? What version number of that image? How many replicas do you want to be running? How much RAM should each of the containers get? How much CPU? What additional metadata that you have? It's pretty straightforward to do, and you can find lots of examples on it. Okay, but that's the first step. You need to define your YAML file, and then you need to launch it into a Kubernetes cluster. You need to start it. And there's a lot of different ways you can do it. One of the standard ways I do is just command line kubectl. And with that, you're able to basically give it a manifest style file and say, this is what I want to see happen. Make it so. And Kubernetes will take that manifest file, and as we said, launch up all the different replicas. It will decide what physical nodes are going to be running the different replicas and so on. Okay. I would encourage you, as you are defining this manifest file, think about how you want to perform updates in the future. Do you want to do a rolling update? Do you want to do some sort of canary system? Do you want to just have blue-green, where you have completely separate different jobs that handle the traffic? Do you want to put a service in front of that application so that you can load balance between the different deployments? So there's a lot of questions that you need to kind of ask yourself and decide on as you're creating that YAML file. Of course, you can always start simple and then build from there. Okay. I think one of the biggest challenges I had with Docker was lack of easy configuration. At Scalyr, we had lots of customers using Docker. They wanted to run our application that collected logs and sent them up to Scalyr in their environment, right? It was difficult in a lot of places to allow them to configure how that log collection agent was run in their Docker container, right? Because we published one image that was supposed to be used by all customers, but each customer had their own API key that they wanted to use. They had their own specific log files they wanted collected, and all these other things. And it was just difficult in Docker. The good news is Kubernetes put in some primitives to make configuring containers much easier. One in particular that I like is config maps. What a config map is it's essentially a key value bag that's stored on the Kubernetes master, and you're able to associate whatever value with whatever key you want, and you can define that. And then when you start up containers, when you start up a deployment, you can make reference to that config map. You can say, okay, run this application, but use this configuration. So each of these different instances of the application can use slightly different configurations. Like, for example, maybe you want to tweak on this thumbnailer service, you want to tweak the compression or the image quality or the allowed image formats, right? Well, rather than having to make those tweaks and bake a new image, you can use the same image and then just use the config maps to do the tweaks. This is an interesting question. Do you need to implement high availability both in your infrastructure and your application? Kubernetes is part of the cloud native computing foundation. This foundation is geared towards what it says, cloud native. Cloud native is all about how do you build highly available, scalable applications. One of the powerful things about Kubernetes is it solves a bunch of the highly available challenges for you, right? It already has a sense of master failover, so that there's already the sense of if your master goes down, it will be switch over to one of the replicas. It already has a sense of monitoring given replicas of your application, noticing when they're down, and then restarting them on other nodes, right? It's already got those things built in. So from a Kubernetes perspective, if you build your application in kind of the model that Kubernetes is encouraging you to, you don't have to solve those same challenges yourself, right? Kubernetes already done the hard work, just leverage them. For us, with our thumbnailer service, we just really have to build a thumbnailer that is able to give a little bit of information to Kubernetes. In this case, the health check. This is how Kubernetes knows if a given application is healthy or not, a given replica is healthy or not. With that small amount of work, then Kubernetes is able to run hundreds of these thumbnailers, such that in aggregate we have 7 nines of availability, as opposed to just the availability of a single dumb thumbnailer by itself. So the quick answer to this is probably not. You probably don't have to build it into your application, but of course all applications have different challenges. Okay, one question that I see on places like Stack Overflow and so on is, do I need to run multiple Kubernetes clusters, right? And I want to talk about this because there's actually a lot to this. From a resource utilization point of view, it makes most sense to have everything in one single Kubernetes cluster, right? As opposed to, maybe you do a two Kubernetes cluster environment where you have a staging cluster and a production cluster. Your staging cluster runs your staging your application in a staging environment, and your production is what your production users use. Okay, that makes logical sense. But the problem from a resource utilization point of view is what happens if not all the CPU and RAM is being used on the staging cluster, but the production server cluster needs more. You can't use that staging CPU and RAM. It's just not available. You can't use resources across clusters, right? So from a resource utilization perspective, it makes more sense to put all your resources in one big pot so that everyone can use them. Now, there's a few reasons though why you wouldn't do that. First of all, Kubernetes, a single cluster, can't scale to a large number of nodes. I think with the latest release, they're quoting, you can run 5,000 nodes. So if your infrastructure requires resources more than 5,000 nodes, then you're just not going to be able to put all your resources in one cluster. You're going to have to divide it up. Of course, there's also geographic region things to consider. If you have different, in AWS parlance, availability zones, AWS regions, you're not going to have a cluster that probably spans regions. And those resources are going to be seen as being kind of different, and you want to treat them differently. The other, a little bit more subtle answer to that is also how do you deal with updates to Kubernetes itself, right? Kubernetes is a project under very active, very high development. They release a new minor version of Kubernetes once every 6 months. And each of these minor versions has a whole new slew of features that you might want to utilize. It has bug fixes that you want to get. And so imagine you're running in this one cluster world where you have all your resources in one Kubernetes cluster. Do you really want to update all the Kubernetes software on that cluster in one go with no qualification? That would be risky, right? So what you would much rather do is have that staging or some other cluster where you can roll out the new version of the Kubernetes software that you want to use there, test it, qualify against your particular application, make sure that all your manifest files still work on it correctly. Once you have confidence, then of course roll it out to your production cluster. Okay, I think the other exciting thing about Kubernetes right now is there's so many other projects that are being built in conjunction with Kubernetes that's helping lift up this ecosystem, that allowing developers to do new and exciting things. And so what I want to do is spend a few moments talking about some of those particular projects. I think Kubernetes operators, this is a topic that's gained a lot of interest, I think, over the last 6 months. And what Kubernetes operators allow you to do is essentially, it allows third-party developers to customize the Kubernetes API itself. And you can essentially build in application-specific behaviors into Kubernetes to do various activities. And this is, I think, most critical for stateful apps. Kubernetes has traditionally had a lot of difficulty being used to run stateful apps. For stateless apps like the thumbnailing service, easy to do. For stateful apps, more difficult. Kubernetes operators is one of the tools that's meant to solve that problem, make it easier to run stateful apps. And the best example of this is you can think of running replicas of a database on Kubernetes. Okay, let's say you have 4 replicas of a database running on Kubernetes. What happens when one of those replicas goes down? In a naive world, Kubernetes would recognize that only 3 replicas are running, a 4th one needs to be run. It would launch it on a new node and start it up and start sending requests to it, right? Well, that new node doesn't have the state for that database. It's empty, right? So that new node is going to be, missing content that it needs, right? What you really want to happen is you want Kubernetes to know that when it starts up that new replica of the database, it needs to first copy over the database into this new node and then start up the database server so that the database has a working copy of the data. And this is exactly what Operators allows you to do. You can define these kind of workflows that need to happen in order to enact kind of application-specific behaviors. In fact, if you look at the Kubernetes page where they document a lot of the third-party operators, I think almost all of them are, well, not all of them, but a large majority of them are around database applications, MySQL, Cassandra, that type of thing. And it's because there's been this pent-up need to solve this problem. And it is operators are kind of this very powerful mechanism, and they're done in a very Kubernetes friendly way. For example, you deploy your operators as images, container images, and you just submit that into the Kubernetes cluster, and it goes from there, and it instantiates as many instances of that container as it needs. Istio and Service Mesh is another I think very powerful technique that is now just becoming available, or you're seeing more developers make use of it, right? Now, service mesh, of course, is just the generic word for describing, you have your application built up of microservices. The service mesh is how all those microservices communicate to one another, right? What Istio does is it interjects itself between all that intra-service communication. So your web application's talking to your thumbnailer, right? Istio gets in there and mediates that communication. And this actually allows you to turn on a bunch of new features without doing any coding changes to either your web application or the thumbnailer, right? It allows you to do authentication. Istio, before it allows the web application to talk to the thumbnailer, it can perform some sort of defined check to make sure that should be allowed, right? It also can do very intelligent load balancing, more so than you kind of get by default. So it can see that the web application wants to send a request to a thumbnailer, and it can send it to the appropriate one based on more application level knowledge. Near and dear to us is it also enables very interesting monitoring. Now, for essentially free, you get the number of requests being sent between each of the microservices. What is the latency for those requests? What's the error rate? All those good attributes, as well as also does some form of tracing as well for free. Now, Istio, this idea of kind of eavesdropping on the service mesh doesn't necessarily need Kubernetes, but Kubernetes definitely eases the burden of running Istio. You can literally get Istio running within minutes on your application, right? And that's because Istio is able to leverage all these primitives that Kubernetes has put in around service discovery and the network and everything else. So it's becoming a lot more popular, and I'm sure you'll see more about it. Finally, I also want to put in a plug for Helm. If you look at the Helm web page, they describe themselves as the Kubernetes package manager, right? And what they're really trying to convey there is they're a way to much more easily run cloud native applications on Kubernetes. Now, Kubernetes came in with the model of they wanted to promote easy use infrastructure as code services, allowing you to specify your infrastructure as manifest files. But in practice, they don't allow for a lot of reuse of those manifest files as they could have. Helm comes in and tries to solve those problems. It adds in the idea of templating to manifest files. It also allows you to essentially import what they call charts, but you can think of them as manifest files from third parties. So if you want to run a thumbnailer from some open source library, you can reference the manifest file that they publish, reducing the amount of work that you have to do. And in general, this just simplifies running Kubernetes applications. You can launch a very powerful and a very large Kubernetes application with essentially one command line in Helm. Okay. And this is also part of the Cloud Native Computing Foundation. So it is seen as kind of the blessed way, the kind of like the way of the future in terms of managing and running your Kubernetes applications. All right. I just want to end the talk on what else you should worry about. And really I wanted to talk about one of the first things you're going to run into as you start playing with Kubernetes, right? And that's that there's many different ways to run and to create and run Kubernetes clusters. You're going to, when you go to create your cluster, you're going to do a Google search for, create Kubernetes cluster. And you're going to come up with probably 5-6 different mechanisms, right? And all these mechanisms will work, but they all represent trade-offs between ease of use and control, right? You have different hosted ways of running this. EKS, Elastic Kubernetes Service on AWS. You have GKE, Google Kubernetes Engine on the Google Compute Cloud, right? These are all services that they run that essentially hide the pain of creating Kubernetes clusters for you, right? So they're easy to use, but they don't provide as much control as you might want, right? If you're really running a large cluster, you're probably going to need to tweak some of the parameters on the Kubernetes master in order to get the scale that you want, right? So there are also manual solutions, and you're going to see things like COPS and Kismatic. And these are tools that allow you to do a lot in terms of controlling exactly how the Kubernetes cluster is run, but it's also going to require a lot more work on or a moderate amount more work on your part in order to get up and running. So, it really just depends on what you're trying to do. I would recommend if you're really just trying for your first Hello World app on Kubernetes, go for one of the hosted solutions. EKS and GKE are pretty easy to use things, and it removes a lot of the worry. So we'd just like to thank you for tuning in to this podcast. We hope that you learned something, got a little more exposure to Kubernetes and its impact on the DevOps world. If you have any interesting discussions or questions, feel free to shoot them our way.
Thanks, Stephen. We appreciate you sharing your DevOps knowledge with us here and your insights into Kubernetes in particular. With that, for Scalyr Insights, I'm Dave McAllister, and we'll talk to you next time.